Hello, my name is Alexandra Reynolds, and Orion and I are talking to you today about pink snow or watermelon snow, which is also pink algae that's growing on top of the glaciers in the Arctic. So, the rapid warming and ice loss in the Arctic is among the indisputable facts that people are researching today. The basic cause is clear, that buildup of atmospheric greenhouse gases from fossil fuel burning, which we've been discussing. But scientists are still struggling to find out why the Arctic is heating up so quickly other than other places on the Earth. They believe that they found an answer to this in this pink algae that has been growing over the glaciers. Pink algae that blooms across the surface of the Arctic snowfields each summer is absorbing heat instead of reflecting it. It is a more powerful contributor to the warming feedback loop than we had ever thought before. The algae causes what is known as that watermelon snow because the ice and snow around it all turn pink. This is responsible for reducing that reflectivity of the snow by as much as 13% on the glaciers and snowfields. The algae turns pink when it reaches full bloom. The color comes from pigments that protect the algae cells from ultraviolet radiation. The more the Arctic warms, the more algae grows, which in turn leads to even more darkening and even more melting. It becomes a cycle. Research teams typically study these glaciers and snowfields in different parts of the Arctic and subarctic, specifically more in Greenland, Iceland, and the north of Sweden. The emergence of this algae has always been more ubiquitous during the spring season. Snowfields, glaciers, pretty much all over the Arctic. This is not a new phenomenon. What may be different now and have an impact on the climate is an increase in algae growth over time and space in response to a warming climate. So for environmental threats, algae causes an increase in flooding due to these glaciers that are melting. Water levels are rising because as this ice is melting, there's nowhere for the residual water to go. This can increase biodiversity, the damage that it causes to ecosystems by changing the pH balance and temperature of the water. This can also interrupt food sources that were once easily available to many animals of the ecosystem. Animals native to the Arctic can also lose valuable land mass that they use to either sun themselves or protect themselves from different predators and others around them. These changes in land mass disrupts their habitats.
You worthless piece of slime!
Now that we've had a chance to look at some of the environmental factors and threats related to pink glaciers, we can take a closer look at the scale of impact that takes place because of this positive feedback loop. Obviously, there's issues with locality in terms of significant temperature changes, the melting of glaciers, and the increasing of algae. A lot of this is derivative of location-specific geochemical and mineralogical factors. Looking at it in a holistic view, as the glaciers melt and the sunlight is absorbed instead of being reflected, it's contributing to making the planet hotter. So on a global level, pink glaciers contribute to global climate change, contributing to issues with ocean levels, and then overall temperature changes throughout the globe. When considering some of the best practices with regards to pink glaciers, it is still somewhat in its infancy stage. Currently, the concept of pink glaciers is still relatively new, and it is not widely believed necessarily that it is contributing to global climate issues. That being said, many scientists have agreed that this is in fact a problem and that new regulations need to be put into place. Things such as the reduction of fossil fuels, the changes of human resources, heavier reliance on renewable energy could all be factors that could help contribute to reducing this issue. One of the biggest things to take into consideration, however, is just the overarching idea that pink algae does in fact have an impact on climate issues across the globe. As such, scientists believe that pink algae should be a large part of future climate models, and that would help at the very least start the process for reducing some of these issues. Although there are a number of variables contributing to global climate change, there's no doubt that pink glaciers serve as a catalyst for this problem. In terms of our impact and the way that we can help alleviate some of these issues, we need to take a look at how our day-to-day life creates some of these problems in the first place. Some of the recent snow albedo models found in Greenland have shown that a lot of the light-absorbing impurities have taken place because of our interaction with the planet. Things such as forest fire, derived black carbon, Saharan and proglacial mineral dust all show that our reliance on different resources can have far-reaching impacts. Our continued reliance on some of these resources are causing problems in the Arctic, which is creating that positive feedback loop that we've discussed throughout this video. Some of the ways that we can help modify or reduce these issues are to increase our regulations in terms of environmental impact, reduce our reliance on different fossil fuels, and then just take into stronger account some of the issues such as pink glaciers and then these algae problems for future climate models. In essence, as we investigate this further, we need to understand that we are having an impact on this as well. So we need to stop the problem at the source to help alleviate some of these issues for the future.